Okay, good morning. So there are two problems left. I will solve them for you because we haven't solved any problems related to inequalities so far. So this example down there, I want to solve that for you. Might be my explanation might be a little bit different from the book, but more or less they are the same thing. So this example I want to solve today. Uh, we want to show that 2 to power n is greater than n squared, but not for all natural numbers. For all natural numbers is strictly greater than 4. But the ideas are the same. That is not something new, but I think it would be good if you see also some kind of proof for inequalities. Okay, so we want to show this. If n is greater than 4, we want to prove that 2 to power n is greater than n squared. By the way, this is also good to know that this is called an exponential function, and this is a polynomial function. And this is probably, it's good to know that exponential functions always dominate polynomial function. Even if, for example, the base here is 2, the power is here is 100, but eventually 2 to power n becomes larger than n to power 100 from some point onwards, yes? But of course here do you want to compare that for n greater than 4. So what we want to show, we want to prove the truth of this inequality. So I call it Pn. 2 to the n is greater than n squared. This is claiming that. So this is usually the case. If you want to prove inequalities, it is better to prove the difference between them. That is easier. Okay, so this is what I'm saying. Instead of proving inequalities, might be this is a good idea to calculate the difference. So instead of calling this Pn, might be that would be a better idea to call the difference between these two greater than 0 to be Pn. Of course, it doesn't matter that much, but this is by experience. I think instead of proving this, it would be better to prove this. They are the same, yes? Because this is exactly the same thing. That if I move this to the other side, I will get this one. And if I get this one, if I move this to the left-hand side, I will get this one. So these two are equivalent. So it doesn't matter if I prove this one or that one. But you will see why might be this is a good idea to do that. Okay, but I am not allowed to start from 1 because this is claiming that this is valid if n is greater than 4. 4 is also not acceptable, so I have to start from 5. So I calculate, I see that if p of 5 is true or false, instead of n I put 5. But is it true or false? This is true, yes, because 2 to power 5 means 32, 5 to power 2 means 25, and the difference is positive, so that is true. Now I assume that P of k is true, but this is also important here. This k is not any natural number, it's a natural number satisfying this condition. So if you don't mind, let me just be more explicit here. So I would say let k be a natural number, greater than 4, and pk assumed to be true, yes? 2 to the k minus k squared positive assumed to be true. Now we want to prove that p of k plus 1 is also true. So p of k plus 1 is 2 to the power of k plus 1 minus k plus 1 to the power of 2. We want to see that this is also positive. Yes, so that is the goal. I want to show that this expression is positive if I know that this expression is positive. So what do you think I will be able to do? So because this is not equality. In equality, you have to make everything 100% the same. In an equality, there is no guarantee that they are exactly the same, but you need to have a nice argument why you are convinced that this is positive. You don't want to show that this is equal exactly to something. You just need to convince yourself that this expression is positive. It doesn't matter if it is larger than 1 or larger than 10. You just want to show it is positive. Okay, so I don't know. What do you think I can do here? Because I want to use this somehow. So what can I, for example, do? Yes?
You bring it down to 1 and you expand the brackets.
What do you mean bring down the 1?
Oh, so you it's 2k times 2.
Yes, so you can write that, yes? So let me start from here. So this is not the left-hand side equal to the right-hand side, yes? So I will start with the left-hand side, but my goal is not to show this is equal to the right-hand side. So let me just write the left-hand side. Don't lose the logic. The goal is to show this is positive under that condition. So as you said, might be that's a good idea. Instead of having 2 to the power of k plus 1, I can write this like that. It is a little bit understandable because what I have is 2 to the power k. And then instead of that one, I can write k, the first one squared 2 times the first one times the second one plus the second one squared. Okay, so now let me open it. Yes? So this becomes 2 times 2 to the power of k minus k squared minus 2k and minus 1. So I don't know, you have to convince yourself that if k is a natural number greater than 4, this is positive. If we also have this, of course. There is no very standard way to do that. You have to think a little bit. If the problem is hard, then of course it might be harder to find the idea. So for example, one mistake that I have seen students make is that they put 4 there and they said that, okay, when I put 4 there, by the way, what happens? This becomes 16 multiplied by 232 minus 16 is 16 minus 8 is 8 minus 1 is 7. And they say that, okay, when I put 4, it is 7, which is positive. So when I increase k, well, definitely it becomes more positive. I want you to see the flaw of this argument. Because there is no guarantee. Of course, if you can prove it, that's okay. But there is no guarantee that all functions are like this, that when you increase the value of the variable, the value of the function also increases. Unless the function is really increasing. If your function is actually of this type, so when I am here, x1 and x2, when I increase the value, it might happen that the value of the function actually decreases. Yeah, so this, if you want to follow this argument, you have to convince the person who is reading what you have written as this is an increasing function. Yes, if you can show that this is an increasing function, and then you show that this is positive for 4, then of course it becomes positive even for the values larger than 4. But that is also the same thing. I mean, that is not that trivial, that why this function is increasing. Okay, so that is probably not a good idea. So what can I do? I see that I have 2k to the power of 2. Can I say that, I will write something and then I ask you, okay, I want to say that this is definitely bigger than 2, and then you tell me why. Instead of this, I write this, but then I copy and paste everything after that. But you tell me, is that valid argument or not? So I am claiming that this expression is definitely greater than this expression. And if you compare these two expressions, I haven't touched this part, but instead of that one, I have written that one. Do you think it is acceptable for you? You cannot answer that unless you look at your assumption. Okay? Because I am not solving it from scratch. I am solving it based on this assumption. Okay, now if you look at this assumption, do you think this is plausible? And if yes, why? What does this mean? When you say 2 to the k minus k squared is positive, this means that this is equivalent to saying that 2 to power k is what? Larger than k squared. Yes? Okay, if 2 to the power of k is larger than k squared, am I allowed to conclude that 2 times that is larger than 2 times k squared? Yes or no?
Yes.
Yes, I just multiplied that by 2. And now look at here. This term appears here. And then I realize that this one is greater than 2k squared. So this term is greater than this one, but the rest of them are the same. So I hope that you agree with me, the whole left-hand side is greater than the whole right-hand side. Is this understandable? So in this inequalities, this is a little bit harder because inequalities you can compare and you realize what you want to reach at, yes? But here you have to be a little bit more creative. But I hope that you understand the argument. So what I did, I had this based on mathematical induction, the hypothesis of induction. I hope that I could convince you that 2 times 2 to the k is larger than 2 times k squared. So this means that only this part is larger than 2k squared. I now hope that you agree that the whole combination is also greater than that combination. Is that clear? Just because everything after that I didn't touch at all. And this term only is larger than this term. So the whole thing is also definitely greater than that. But then I can continue this a little bit because now 2k squared minus k squared can be simplified. So what can I write? This becomes now equal k squared minus 2k minus 1. So what I have shown that this expression, is equal to this expression. This expression is greater than that expression, but this expression is equal to this expression. So I hope that you agree with me that this expression is greater than this expression so far. Yes? Is that clear? For example, like this. If I say A is equal to B, B is greater than C, C is equal to D. What can I say about A and D? A is definitely larger than D itself. Yes? Is that clear? That's the same argument. A is equal to B is equal to C, C is greater than D, D is equal to E, so it means that this is larger than that. Okay, but it's now hopefully clear. Still, I cannot say this is positive because there are many minus signs involved. Yes, we have to show that which one will dominate. Of course, this part is positive, but I have two negative parts. It is not very clear that this is positive or negative. You have to come up with a good idea. But why this is the case? It is not a squaring pattern because I have a minus sign here. But then I can write it as k squared minus 2k plus 1 minus 2. Do you agree? Because instead of minus 1, I can write plus 1 minus 2. You might say, why I'm doing this? The answer is also clear, so you can write it as k minus 1 to the power of 2 and minus 2. But can you be certain about that this is positive? k minus 1 to power 2 is non-negative. But unfortunately, I am not adding something to it. If it was k minus 1 to power 2 plus 2, then it is done. Because this is non-negative, and if it was plus, then it definitely becomes positive. But unfortunately, this one is positive. This one is negative. It might happen that this is dominating this one, and then the answer becomes negative. But in this case, that cannot happen. Why? And that is why I mentioned here. Yes? So the k is a number greater than 4. And now I am sure that this part is increasing, yes? When I start increasing the value of k minus 1 increases, so k minus 1 squared also increases. So this means that I can clean this. Here I am completely sure that this is greater than 4 minus 1 to power 2 minus 2. Is that understandable what I have written? Because k is greater than 4, so this combination is definitely greater than that combination. But this number is very easy to calculate. 4 minus 1, 3, 3 to power 2, 9, minus 2, 7. This is 7. So what I did, I was able to show that this number is greater than 7. But when it is greater than 7, it is also automatically positive. So this is also positive. This means the problem is solved. Okay. This might be a little bit confusing. Let me change the strategy. That might be better for you. But I would say that solving inequalities is a hard problem. So let me take this slide away. Okay, so let me repeat it again. So for example, assume that you want to solve this problem. First of all, tell me, do you understand what is going on? It might be a little bit convoluted, but each piece is very simple to understand. But of course, this problem happens, okay, how should I understand to do these things? Then you have to practice a lot, okay? And of course, it's always possibility that you cannot solve the problem. This is natural mathematics, yes? Okay, so what we do here, let me just solve the problem in a slightly different way. Might be that is easier for you. So if I want to prove, let me don't do any changes. I start for writing Pn, but remember, n is greater than 4. Okay, p 2 to the n, I want to show it's greater than n squared, so I assume that I calculate p5, because the first number that I'm allowed is this one, and this gives me 2 to the power of 5 is greater than 5 to the power of 2, which is true. And then I assume that k is greater than 4. This is my assumption, and I assume that p of k is true, meaning 2 to the power of k is greater than k squared. Assumed to be true. Okay, and then what you do, you write p of k plus 1, which is 2 to the power of k plus 1 greater than k plus 1 squared. To be proven. I'm doing the same thing, but might be the algebra here is easier for you to understand. So here I didn't change anything. I just started with the problem itself. Okay, I want to prove this. Instead of starting from here, I start from what I know, try to manipulate it in a way that I can little by little get closer and closer to what I want. Yes, because this is a fact, assumed to be true, so I can rely on this part. And I will try to do something that this expression, little by little, gets the form of this expression. I want to get closer and close to this one, if possible. Of course, for inequalities, most of the time it is not possible. And that is the hard part. Okay? So, what do you want to do first? I start with this one. 2 to the power of k is greater than k squared. I want to start from here, which is assumed to be true, and I want to reach to this one. What is the first thing that comes to mind? Yes?
Multiply both sides with 2.
What with 2? Because at least there is no clear way to go from here to here, but there is a very clear way to go from here to here, and that is multiplication by 2. And you already know that if this number is greater than that number, definitely, let me write with double arrows, 2 times this one, which is, you don't need to put double arrows will be later important. So I will multiply this by 2, and then 2 times 2 to the k is this one. Yes? Okay, so this was not hard because you told me to do this. So it is clear. But from here, there is no way apparently to go from here to here, because this part is the same. So I am not allowed, I don't want to touch it more, because then I will destroy it. This is already in the correct form. But then 2k squared is unfortunately not in the correct form if you assume that k plus 1 squared is the correct form. So then it means that you have to change your strategy from now on. My goal was to show this number is greater than that number. Did I succeed to do that? No. But in return, I succeeded to show this number is greater than that number. If I can somehow show this one is greater than that one, then I am done. Is the logic clear? So I wanted to prove this. I couldn't. So far, I was able to show this. This is not what I want, but if, this is a big if of course, if I can show this one is greater than that one, I am done. First of all, tell me, do you understand why? Yes or no? If A is greater than B, B is greater than C, what can I conclude? A is greater than C. So if I give the role of A to this, if I give the role of B to this, and if I give the role of C to this, my goal is to show that A is greater than C. This is my goal. But so far, I was able to show that A is greater than B. If I can show B itself is greater than C, then I am done. So then you need to write this. So, therefore, if we can show that 2k squared is greater than k plus 1 squared, we are done. Just tell me, do you understand this sentence?
Yeah.
Because that's the only thing. Yeah? So I wanted to show this. I didn't succeed to do that, but in return, I was able to show at least this one. Then I say that if I can somehow show this itself is greater than that one, then I am done, because I know this is greater than this. If I can show this one is greater than that one, then it means this one is also greater than that one, and that's exactly what I want. But this is now, I tell you, this is simpler than the previous method. Why? Because you come here and say, let us simplify this algebraically. Okay? If I ask you, is it guaranteed that this is greater than this one? Still no. I don't have any real reason why this should be always greater than that one. I have to make sure that this is always the case. Okay, so then what I'm saying is that you start simplifying it. But simplification is extremely simple. So just write 2k squared, nothing to simplify here. But then I raise it to power 2k squared plus 2k plus 1. Okay? But the point is extremely important, because I don't know if it is true or false yet. So I cannot start from something I am not sure about to conclude something. Because if it is doubtful for me, what I am concluding below it is still doubtful. Yes? Unless, this is important, this arrow should be double-sided. So it means that you have to convince yourself that what you are doing is reversible. Yes, this is important. So it means that this is it reversible for the time being or not?
Yes.
Yes, because if I give you this, you can expand this and write that. If I give you this, you can collect it, write that. So this is reversible. And let us simplify that. How can I simplify? I can, for example, take k squared. I can take everything to the left. Or I can just take these two to the left, okay? So k squared minus 2k squared becomes k squared, and then minus 2k, and then what is left on the right is 1. So if you give me this, I can conclude this, and of course, if you give me this, I can return back to this one by writing k squared as 2k squared minus k squared in between the guys. But then, is this true or not? Because it's still not very clear. K is a number greater than 4. So I am raising it to power, but subtracting 2k from it. It might happen that it goes below 1. I want to show that, no, this cannot happen. So you have to have a good argument for that. So what can I say? For example, this combination is famous, so I would add 1 to it. And then when I add 1 to it, I have to add 1 to it as well. So this means that if I give you this, you can conclude this and in reverse order. And then this one, what can I write? I can collect it back in this form and greater than 2. If you give me this, I can conclude this. If you give me this, I can go back. What does this double-sided arrow in mathematics mean? It means that this statement is exactly equivalent to that statement. It means that if this statement is true, this is also true. If this is false, that is also false. That is the meaning of equivalency in mathematics. But now all of them are double-sided arrows. So it means that this expression, which I was doubtful about, is equivalent to this last expression, last inequality. So validity of this one depends, that would be exactly the same as the validity of this one. But do you have any reason to believe that this one is true? Yes, because k is greater than 4. If k is greater than 4, this combination is greater than 3, so the whole combination is greater than 9, and this is guaranteed to be greater than 2. So the last one I am certain about to be true. Because every step I check that all of them are reversible, if the last one is true, it means the one that I was doubtful about is also true. That's it, and I am done. So I don't know which you prefer. So the book probably works with that idea. So this is also good, because if the problem becomes hard, even I don't know. This is the way I do it. I go to a scratch paper, I start calculating, simplifying things to see that at the end of the day, do I get something that I can rely on to be true or false or not? Okay? Is that clear? Okay, so if you don't mind, let me solve one of these problems in level 3 problem here. I think it was here, yes. Let me solve this problem. Or if you want, you can give it a try first. This would be the last problem I will solve, and this chapter is finally finished. Okay? So it would be a good idea if you solve this one, or try to solve this one yourself, and then we come back and solve it, and then we end the lesson today. Is it readable here? So let me bring it higher. Yes, this problem. Bigger. Just a moment. Yes, problem 1254. Could you solve the problem? Okay, let us see why. So the first parts are actually very simple. So we call this Pn, and there are no restrictions given for n, so I start with 1, because they haven't mentioned something for all integers, yes? All positive integers. So this means that I have to check if P of 1 is true or false. What is P of 1? I have to replace every appearance of n with 1. Okay, what will happen for the left-hand side? If I give you n, you start from 1 to power 2, you increase it one step at a time, 2 to power 2, until you reach to n to power 2. But when n is 1, you just start and stop, yes? So this becomes 1 over 1 to power 2. is less than or equal to, instead of n, I put 1. But this is easy to check if this is true or false, because this number is nothing except 1 less than or equal to. If you calculate, this number is also 1. Is it true or false? 1 is less than or equal to 1, of course, is true. Yes, it is not less than, but it is equal to. When you say or, either this one or that one or both. Okay, so that is true. So then I would assume that P of k is also true. So this means that I change n to k. Then this is assumed to be true. And what I need to do now, I have to write the same thing, but this time for k plus 1. And you have enough experience by these dots, yes? So what is better to do? Of course, in principle, you don't need to do that, but it is always better to do it. So when I put k plus 1, it means that I start from 1 and then I go to k plus first step. But by the experience you have gained so far, you know that it is always good to write the previous or some previous term. So what is the previous one then? Of course, k plus k squared. And then on the right hand side, I would say that this is 2 minus 1 over k plus 1. Okay, so that is, your hands are open. That is depends which way you want to do it. For example, in inequalities, might be it is better to start from what we know and try to construct what we want. Yes, so this is something we know. This is something that we want to prove. Okay, so look, I have this in my hand, and I want to do something on it so that I can get close as possible to this. You need to remember, for equalities, you have to produce exactly the same thing. But this restriction is no longer valid when it comes to inequalities, yes? And most of the time, this cannot happen, that you can start from here and get exactly what you want. Okay, so you have to do some argument. But at least it is not that hard to understand what to do, at least for the first step. So if I give you this, which you are assuming to be true, and I tell you do something so that you can get close at least a little bit to this one that you want to prove. What do you want to do first? Yes?
You replace the first part by
There is no replacement here. By the way, this is very easy. This one is not equal to this one, so that I can replace it with that one. They are not equal. You understand what I mean? If this is equal to this one, then of course I can replace it with that one. Yes? So what I do? It's not hard. So you want to come from here to here, do something at least, yes? So compare. There is nothing immediately comes to mind. What change I have to do here to come here? Because the denominator k suddenly becomes k plus 1. But there is easy to see, how can I go from here to here? What should I do? Yeah? You add this expression. Yes, that's easy. So you start from here, that you know, and then you add that expression. So this means that 1 over 1 to the power of 2 plus 1 over 2 to the power of 2 up to plus 1 over k to the power of 2. Yes, I add this term to the left-hand side of that, which becomes what? This one. When I add this to this left-hand side, if I add the same thing to the right-hand side, this is still become less than that one. Yes? So let me just write, might be you understand better than my explanation. So 2 minus 1 over k plus 1 over k plus 1 to the power of 2. Do you agree that if this is true, which is assumed to be true, I can also conclude that one is also true? Is that right? What I have done, I have taken this one that you have given to me to be true, I added the same amount to both sides. That same amount is 1 over k plus 8 squared. So this is still, this one should be less than that one. Is that clear? Okay. But is it what I want? Unfortunately not, yes? Because I want to show this one is less than this one. I didn't succeed to show this, but instead I succeeded to show this one is less than that one. Okay, so that is the if part. Now if, what happens then I am done? In equalities, you have to get exactly the same thing. But in inequalities, might be you get, might be you don't get, but still the inequality holds, yes? There's no guarantee. So can you tell me what to do? I want to show this is less than that. I was not able to do that, but instead I was able to show this one is less than this quantity. If I can show that, I want you to write it down. If I can show that, what? Then I am done. So if what? Let me write it like this, because this is extremely simple, yes? I want to show that A is less than or equal to C. This is my goal. Forget about these details. This is my goal. I could not do that, but instead I was able to show A is less than or equal to B. My goal is this, but I couldn't do it. Instead, I was able to show that A is less than or equal to B. Is there still a chance to be able to show this is also true? Yes or no? You shouldn't be actually desperate here, yes? In equalities, that is the end of the problem. We cannot do anything. But still there is a chance that I can go and prove this. If I can succeed to show
that B is less than or equal to C.
C. Do you agree? Is that clear? So my goal is to show this. I wasn't able to do that. I was able to show this. I do not lose hope. There is still a chance, yes? And then that is, if I can show that now, if I write this in this language, then it means that if I can show that 2 minus 1 over k plus 1 over k plus 1 squared is less than or equal to 2 minus 1 over k plus 1, then I am. Okay, I want to wait for you. Is that everything understandable? I wanted to prove this. I couldn't. I was able to prove this is less than that one, circled around. Then I would say that, okay, don't worry about that, it's a still chance. If you have this one less than that one, then I am done. Because I was able to show this is less than that, if I can also show this one is less than this one, comparing this one, I am done. Is that clear? Now, this is now far away from mathematical induction finishes here. So the goal is that I want to convince myself about that which is not trivial. Why there is guarantee that this combination is less than that combination. So you have to convince yourself in a very strict way. Yes? How do you do that? The trick that I told you. Try to simplify this as much as you can, but in each step you have to convince yourself that this is reversible action. That's it. So what I do, I go back here. So let me take this off. Yes. So here, I would rewrite it here in front of your eyes. So 2 minus 1 over k plus 1 over k plus 1 to the power of 2 less than or equal to 2 minus 1 over k plus 1. Okay, you want to simplify it. So I put this arrow. The first thing comes to mind. What do you think I will do? It seems that I move 2 to the other side, minus 2, and they are gone, yes? So that is probably a good starting point. And then I would have this less than or equal to minus 1 over k plus 1. Now tell me, is it reversible action or not? I was able to go from here to here, still I can go back by adding 2, so that's reversible. So what does it mean? It means that as far as mathematics is concerned, there is no difference between the truth or falsity of that and the truth or falsity of that. But the truth or falsity of this one is easier to understand because it is simpler in form. And I am doing it with this hope that I can make it so simple that I can really see that this is true. Okay, so what is the next step? I don't know. Whatever you want to do, you can do that. So for example, I really don't like fractions. I want to get rid of fractions. Okay, so I multiply everything by, what do you think? K times k plus 1 squared. Do you agree?
Yes.
Because I want to get rid of all fractions simultaneously. So I multiply everything here. So let us do it in our head. I multiply this by the first one. There is a minus sign. This k cancel that k. K plus 1 squared is left. I multiply it in the numerator. So this becomes minus k plus 1 squared. And then here, plus, I multiply that by that, this, and that are cancelled. K is left. Multiply it here. It's k. And then less than or equal to, I multiply this here. There is a minus sign, so let us keep it. This k plus 1 cancels one of them. 1k plus 1 and 1k are left. So this becomes k times k plus 1. Yes? But you have to be careful because you are working with inequalities, not equalities. Am I allowed to multiply inequality by that? Yes or no? There is some point you have to be careful. Yes, in this case, yes, but you have to be careful about that.
Unless k is 0.
No? K shouldn't be. Yes, if what you are multiplying is positive, you can multiply and keep the direction. If what you are multiplying is negative, you still can multiply, but you have to be careful to reverse the direction of inequality. But in this case, because I am working with natural numbers, these are positive. So this arrow in this direction is possible. Is it reversible? Is it reversible? Yes. This time I can divide everything by this, and I will go back. And division is also possible because k is a natural number. Okay? But still it is not clear. It is not clear why this is definitely smaller than that one. So still we haven't reached to that point. So I continue simplification. So what should I do? I raise it to power 2 multiplied by minus sign. Minus sign will be for all the terms involved. So k squared minus sign minus k squared. 2 times the first one times the second one minus 2k. The second one is squared minus, and then I have plus k, and then less than or equal, I multiply that. So this means that if you give me, I can get this one. Is this action reversible? Yes. And let me simplify things. Minus k squared, I move it in my head to the other side. This will cancel that one. Okay? So then what happens? By the way, it's extremely simple now. You cannot deny it, because if I move minus k, let me simplify. Minus 2k plus k is minus k, minus 1, and less than or equal to minus k. Yes? So this is also reversible, but this is a fact. If you still doubt it, you can just go continue. You can move minus k to the right, 1 to the right. Sorry, minus k to the left, 1 to the right. So this becomes, if I move minus k to the left, it becomes 0. I move minus 1 to the right, and then hopefully you cannot deny that. So this means that, what does this mean? The last statement, is it true or false? 0 less than or equal to 1. It is true. And then because all these actions are reversible, it means each line is a statement which is equivalent to this one. And because this is true, The first one, which I didn't know was true in the beginning, now I know it is true. Yes, because it is equivalent to saying this. And this is true. So this means that I am. Yes, so that is the trick with inequalities. You shouldn't expect to get exactly what you want. So you need to start writing everything and then start focusing on one part which is easier to construct and then try to have these kinds of arguments. Yes, so that you can prove the problem. Okay, any questions? So I think now it is good to actually stop, because if we can solve mathematical induction problems forever. So, but it is better to stop here. Now you have a lot of experience. So you learn how to prove equalities. You realize how you use it in number theory, and then how can you use it for proving inequalities. The people who had mathematics specialization, they also learn how they can use it in matrices. Yes. So whenever you have a statement regarding natural numbers, you can use the idea of mathematical induction. Okay. Any questions? So this session, if you want, you can practice after that, and then one session on Monday you practice, then I will continue to the next chapter, which will not, of course, be included in the exam coming, yes, on week 14 now. Yes. No questions now? Okay.